Hello everyone. In this video, I shall solve exercise 1.3.10 and 1.3.11. So write the negation of the statements B and C, where B and C are as given below. So statement B says, there exists X in X such that X does not have property P or Q. Now P or Q, you can think of that as one property itself for now. So its negation will be what now? So its negation, that is not B, will be for all X in X, X does not have property P and Q. X does not have property P or Q. Now, what do you mean by saying that X does not have P or Q? It does not have P and it does not have Q. So the final negation would be, not B, would be for all X in X, X does not have property P and X does not have property Q. Or another way would be for all X in X, X neither has property P nor Q. That means it is not having Q and it is not having P also. Okay, I hope that is clear. Looking at statement number C, for all X in X, X does not have P and Q. Now think of this as one property, P and Q. So its negation would be for all X in X, sorry. Now for all will change to there exist. So I'll erase this. So this will change to there exist. There exists X in X such that X does not have property P and Q. X does not have property. The name of the property is P and Q. And now further, the final negation will be what now? If X does not have P and Q, that means at least one of them it is not having. Right? So there exists X in X such that X does not have property P or at least one it should not have. Sorry. Or X does not have property Q. Or X does not have property Q. Okay. So this will be the final negation of the given statement C. Now moving on to exercise 1.3.11. With S as the students in the class, P and Q as the properties being intelligent and being hardworking respectively. First, write the following sentences as mathematical statements using quantifiers, then negate them, and then finally write the negation in plain English. So first let's try to write it in plain English. So I'll call this one as A, let's say. So using quantifiers, how can I write it? Now the set of context is already given to you as the set is properties P and Q are being intelligent and hardworking respectively. So there is a student in the class. So there exists a point X in S. S is the set of context such that who is hardworking or intelligent, such that X has property P or Q. That means that student is either intelligent or hardworking, right? So now, how will you negate this? So its negation would be not A. Using quantifiers, for all x in S, x does not have P and x does not have Q. X does not have property P and x does not have property Q. Correct? Because the original sentence was saying there is a student who has either property P or Q. So for it to be false, given any student, he should not have either of the properties. So that student does not have property P and it does not have property Q. So in plain English, how will I write the negation? For so given any student in the class, that student is neither having property P nor it is having property Q. So given any student in the class, he or she, you can say now, he is neither intelligent nor hardworking. So this will be the negation of the given statement using plain English. Right? Looking at sentence B, every student in the class is hardworking or intelligent. So if I call this as statement number B, so first using quantifiers, let's try to write the given statement. Every student in the class, for all x in S, what is said about x? Every student in the class is hardworking or intelligent. X has property P or Q. X has property P or Q. So what will be its negation now using quantifiers? So using quantifiers, its negation not B would be there exists X in S. Now how will you negate this? X has property P or Q. Same as the previous one. X does not have property P and X does not have property Q. So it is not having any of the two properties. So using plain English, how will you write the negation? There is a student in the class who is not having property P and who is not having property Q also. So there is a student in the class. There is a student in the class who is neither intelligent, nor hardworking. So this student does not have any of the two properties P and Q. So this will be the negation of the given statement in plain English. I hope this is clear. Moving to sentence C, I'll call it capital C. So let's try to write it using quantifiers. There is a student in the class who is hardworking and intelligent. So now you have and as the conjunctive here. So there exists X in X is such that X has property P and Q. Intelligent and hardworking. So what will be the negation of this? There exists will change to for all. For all X in S, we have to negate the inner statement now. X has property P and Q. So for this not to happen, X should not have it should not have at least one of the properties. X does not have property P, or X does not have property Q. So at least one property it should not have, right? So what will be the negation now? Given any student in the class, he is either not intelligent or he is not hardworking. So at least one property is being failed here. So given any student in the class, or you can say every student in the class, I can slightly change it. You need not say given every time. Not C. Every student in the class how will I frame this? One second. Every student in the class should not have at least one property. Every student in the class is either not intelligent or not hardworking. Every student in the class is either not intelligent or is not hardworking. That will be the negation of the given statement C. Now looking at the last one, every student in the class is hardworking and intelligent. So here now if you see, you have a universal quantifier. I'll call it D. So using quantifiers, how can I write D now? Using quantifiers, I can write D as for all x in S, X has property P and Q. Right? So now to negate it using quantifiers itself, it will be there exists X in S such that X now X does not have X has property P and Q. So its negation is X does not have property P or X does not have property Q or X does not have property Q. So at least one property it is lacking, right? So now using plain English, we have to frame the negation of this. So there is a student in the class, at least one student is there in the class. So there is a student in the class who is either not intelligent or second property is hardworking or not hardworking. So at least one student is there in the class who will fail one of the properties, right? So that finishes exercise 1.3.11. Thank you.